Unification is the heart of our type inference engine, so let's look at examples of the unify function. Unify takes two types and makes sure that they are compatible. And when it succeeds, as it does when unifying the number type with the number type, then it returns no values, as shown here by values with no arguments. But the fact that it doesn't raise an exception is why we know it succeeds. Boolean can be unified with Boolean, but if we try to use the number type, unify the number type with the Boolean type, then it fails with a no type exception. Our actual unify function is going to take a third argument, which is an expression that's used in the reporting the no type exception. I'm just leaving it out for these examples. If we have a type variable, like this, here is a type variable that currently has no assignment, so that can be successfully unified with any type, including numt. If we have a type variable that's already unified to numt, already assigned to be a numt, then unifying that with numt also succeeds. On the other hand, if we have a type variable that has already been assigned to a Boolean type, then unifying it with numt will fail with a no type exception, the same as trying to unify Boolean and num type. Now, normally we don't see var types created with already an assignment. We create a var type with no assignment. So here I have bound that to t so that I can unify it twice, once with num and once with bool, in which case I get no type. This first unification succeeds and causes the type variable t to be assigned to num type, so that when I try to unify it with Boolean, it fails. If I take this similar example, same variable t, and I unify it twice with numt, both of them succeed. The first one causes the type variable to be assigned to the type numt, and the second one confirms that the current assignment to numt is compatible with numt. If I have a type variable, it can appear inside of an arrow type, like this. And if I unify two arrow types, then the recursive calls to unification cause t here to be unified with the number type, so that if later I try again, unifying with the number type succeeds. If I unified t with bool t here, then it would fail instead. If I try to unify an arrow type containing t with t itself, this is where the occurs checks must kick in, because t cannot be equated to an arrow t with t inside. We could have two type variables, t1 and t2, that get unified, in which case unification simply succeeds and also sets up an equivalence. It records that t1 is equivalent to t2. If we then further unify t1 and t2, then it may or may not work. For example, here I've unified t1 and t2, then I've further unified t1 to numt, which has the effect of making t2 also numt, and so if I try to unify t2 with bool t, then it will fail. And more precisely the way this works is t1 gets assigned to t2 in this first unification, and then when we try to unify t1 with numt, it's already assigned to t2, so really we're unifying t2 with numt in this case. And finally we try to unify t2 with bool t, but t2 has already been recorded as being numt, and that's why it fails. If we swap the order of things, then it's still pretty similar. t1 is equated to t2, t2 gets unified with bool t, so t2 is assigned to bool t, and now once again, because t1 is assigned to t2, then we end up unifying t2 with numt, and it fails because it was already unified with bool t. Finally, here's an example with multiple type variables and arrow t's. So here we unify t1 with arrow t t2. That causes t1 to be equated to this arrow t. Then when we unify t1 with arrow t in this case, then t1 has already been equated to an arrow t, so we end up unifying these two things, this arrow t and this arrow t. In the process, we unify t2 to numt, and then we try to unify bool t to t2. But this unification assigns t2 to numt, and so bool t and numt don't match, and the unification fails.